Hello students. So uh, we are in continuation of electric charges and field. So today we are going to discuss a little bit about linear distribution of charges and surface distribution of charges. Okay, in case of linear distribution of charges, we know if we consider infinitely long linear distribution of charges, for example like this, where lambda is the linear charge density, this is charge per unit length, then what will happen from this particular distribution of charge at a distance r, electric field will become lambda divided by twice pi epsilon naught r. This one we have already seen, okay, where you can call electric field is inversely proportional to r. If we plot a graph showing the variation of electric field with distance, then we get an inverse curve, okay, inversely proportional. Clear? Instead of infinitely long linear distribution of charges, if we use a finite one, then at a distance r, okay, suppose making an angle alpha with one end and angle beta with the other end, at this particular point we'll be finding electric field as lambda divided by 4 pi epsilon naught r within bracket sine alpha plus sine beta, within bracket sine alpha plus sine beta. Okay, so here I'm just showing the directions of magnitude only. So in case of application of it, for example, we are using two infinitely long linear distribution of charges. I'll be discussing some simple cases. Okay, this is suppose having lambda 1 as LCD, okay, and then this particular side, the other one is lambda 2 LCD, linear distribution of charges. We have to find at what distance from the first is the second, at what distance, suppose separation between them is r. Question is at what distance from the first the net electric field will be 0. Okay, let me consider that particular distance to be x. Suppose at this particular point electric field is 0. If I consider this distance to be x, then remaining is what? R minus x. Clear? So at this point I can assume both the electric fields to be in opposite direction. This is E2, this is E1. E1 become towards right and E2 become towards left. They are opposite, and once they becomes equal, net field will become equal to 0. So then I have to write E1 is equal to E2. In magnitude they will have to be equal, in direction they are opposite. Okay, so E1 is nothing but lambda 1 divided by twice pi epsilon naught x from here. Okay, I have to get the value of x. At what distance from the first? Okay, I need to get the value of x. E2 is nothing but lambda 2 divided by twice pi epsilon naught r minus x. So you'll be getting lambda 1 by x is equal to lambda 2 divided by r minus x. Okay, so if you go for cross multiplication, lambda 2 into x plus lambda 1 into x is equal to lambda 1 into r. Lambda 1 into r minus lambda 1 into x will come to the r this side. So x is taken common. So lambda 1 divided by lambda 1 plus lambda 2 into r. So this is the distance at which net electric field will become 0. Okay, this is one question. Let me discuss here another point. Suppose a distribution of charge is like this: a straight line, semicircle, then another straight line. Clear? This is again having everywhere lambda is the linear charge density. This is a center, this is a radius r. Okay, find net fill at the center. Okay, इस सेंटर में नेट फिल निकालना है. आप सोचो, वीडियो को पॉज करके आप कैलकुलेट करने के लिए कोशिश करो नेट फिल आपका निकालता है कि नहीं निकालता है. ओके, जस्ट टेक 1 मिनट. How much you'll be getting? How much you'll be getting here? Okay, this is going to infinity. This side also is going to infinity. Clear? At one end of a infinitely long linear distribution of chairs. यहाँ पर 3 field होगा. इसको मैं कहता हूँ 1, इसको कहता हूँ 2. This one let me call as 3. Because of 1 at the center, electric field will become towards right, E1. Because of 2, electric field here will become E2. So for this semi-infinite, what electric field will become towards left? For this semi-infinite, same electric field will become towards right. Let me call it as 3 E3. So E1 and E3, they will become equal and opposite. They will cancel each other. Remaining is the semicircle. For the semicircle, it will be downward. Okay. So here net electric field will become E2. How much will become net electric field? E2. And what is the electric field? Because of a semicircular ring, as I have shown you earlier, it is lambda divided by 2 pi epsilon naught capital R, where capital R is the radius. Where capital R is the radius. Okay, इसको आप verify करो. So I'm going to the next page. Okay. I'm going to next page. So in this case of semicircular ring, on at one end of a, for example, this point we have discussed earlier. If there is a linear distribution of charge like this, what will be the electric field at one end at a distance r? यहाँ से distance कितना है? R. This length is what? L. Lambda is what? LCD. At this particular point, what is the electric field? Okay, these derivations we have done earlier, but just to remind you, this electric field at this particular point, you can use lambda also, or you can use Q also. Q is the charge here, net charge, which is nothing but lambda into L. We can replace it by like this. So this electric field at this particular point, we can replace it by Q divided by 4 pi epsilon naught. This distance is R into R plus L. We can do it like this. Or Q, you can replace it by lambda L. You can write it like this also. KQ divided by R into R plus L. Or you can write it like this also. K lambda L divided by K lambda L divided by R into R plus L. Like this also you can say at one end. Okay, but when this particular linear conductor, when one end is going to infinity, okay, that means instead of R, R is okay. At a distance R is there, but this L is going to infinity. This side L is going to infinity. Then how to do it? How we exactly is going to do it? I'll show you one thing. Here, exactly the way we have used the method earlier. Let me show you that again, repeat it. Let me consider a small element dx at a distance x here. This element dx will have a charge dq, where dq can be written as lambda into dx. So because of this dq, there will be electric field along this direction de, and this de will become nothing but k dq into distance square. K, this dq is nothing but lambda dx divided by x square. So when you integrate, when you want to find the total electric field, it will be sum of all the electric field produced by all possible elements. See, if I consider another dx out here, this dx will also produce an electric field in this direction, small electric field. So for all the small elements possible, we'll have to consider the electric field, which will be always towards right. So net electric field will be integration of all these electric fields. Okay, so net electric field will become k lambda dx divided by x square. Here value of x, yani this nearest element dx is at a distance r, and the one which is far away is at infinity. So this limit of integration will go from r to infinity. In this situation, same integration will come. In this situation, the nearest dx was at a distance r, and the farthest dx was at a distance, at what distance? At a distance of l plus r. So here limit of, in this situation, the limit of integration was going from r to r plus l, but here the limit of integration is coming from r to infinity. Clear? So when you integrate it, k lambda integration 1 by x square will give you minus 1 by x r to infinity. So this will become how much? K lambda, minus is there, so I'll put a lower limit. Okay, 1 by r, and 1 by infinity is equal to 0. So this is going to be your answer, k lambda. So lambda divided by 4 pi epsilon naught r. This is the electric field at one end of a semi-infinite, okay, at one end of a linear conductor whose one end is going to infinity. Lambda divided by 4 pi epsilon naught r. Clear? So like this we have to discuss many more problems. Now another point out here, infinitely thin plane sheet of charge. Infinitely thin plane sheet of charge. इसमें कितना होगा? This one also known to us, infinitely thin plane sheet of charge. We can find it with the help of Gauss's theorem. We don't have to go for derivations of it. We have already seen that when we were in class 12. You are class 12 pass students. Okay, sigma is what? Surface charge density. Okay, this is infinitely thin. That means same charge is visible from either side. Very thin sheet. Okay, that means you do not have 2 or 3 or 5 layers or something like that. Okay, just theoretically. So from here, at a certain distance r, what will be the electric field? This one we have done already with the help of Gauss's theorem. Sigma divided by twice epsilon naught. Okay, considering a Gaussian surface here, if you remember, okay, which will become cylindrical. Can consider to the other side also. Consider to the other side also. Okay. So here the flux with the, so we have got finally a cylinder. This area is A, that particular area is A. This is a cylindrical surface. This is a cylindrical surface. Okay. There is a curved surface. The flux with the curved surface is 0, and flux will be associated only with these two plane surfaces because electric fields will be going out. Electric fields will be going out. So total flux will become electric field into area, electric field into area, electric field into area. This flux is going out positive, this flux is going out positive. Okay, so total flux will become nothing but twice, okay, electric field into area, which is nothing but 1 by epsilon naught times charge enclosed. What is the total charge enclosed? Okay, so area enclosed by the cylinder from the thin sheet is how much area it is getting enclosed? A. So charge enclosed will become sigma into A. What is sigma? Charge per unit area, and area enclosed is what? A. Clear? So area is getting cancels. From here your electric field will become sigma divided by twice epsilon naught. Sigma divided by twice epsilon. This is the electric field at a certain distance from an infinitely thin plane sheet of charge. Okay, plus. So in front of it, electric field is what? Uniform. Okay, E is equal to sigma divided by twice epsilon naught. So if you plot a graph showing the variation of electric field with a distance, this particular graph goes like this. Clear? So from here, if you want to go ahead, instead of one plane sheet of chairs, if you consider two plane sheet of chairs, this is one plane sheet of chairs having surface charge density sigma 1, and this is the other plane sheet of chairs having surface charge density sigma 2. This is region 1, let me call it region A, let me call it region B, let me call it region C. So at this particular point, there will be two electric fields, one due to sigma 1, the other due to sigma 2. So this is E1, this is E2. On this side, because of sigma 2 will be towards right, because of sigma 1 also will become towards right. Sigma 2 is what? Oh sorry, E2 is what? Electric field because of 2 sigma 2, that is sigma 2 divided by twice epsilon naught. This is also sigma 1 divided by twice epsilon naught. This is epsilon naught. Here also same situation. Okay, but at the middle point, in between, not in middle point, in between, E1 will become towards right and E2 will become towards left. Everywhere E1 is equal to sigma 1 by twice epsilon naught and E2 is equal to sigma 2 by twice epsilon naught. So therefore, net electric field in the region A. Now let me do one thing. The right direction, let me call it as positive, and left direction, let me call it as what? Negative. Then sigma A in the region A, sigma A will become E1 is equal to minus sigma 1 by twice epsilon naught and E2 is equal to minus sigma 2 by twice epsilon naught. That means if I take 1 by twice epsilon naught common within bracket, sigma 1 plus sigma 2. In a middle region, electric field in a middle region, EB. EB is nothing but E1 minus E2. What is E1? Sigma 1 by twice epsilon naught. What is minus E2? E2 will become towards left. I have to consider as negative. Minus sigma 2 by twice epsilon naught. So I'll write sigma 2 like this. Sigma 1 minus sigma 2. Similarly, electric field at region 3, both are towards right. So I'll take 1 by is common, 1 by twice sigma, twice epsilon naught within bracket sigma 1 plus sigma 2. Right. So now here let me tell you quickly revised few different situations. Case 1, sigma 1 is equal to sigma 2 is equal to sigma. What are sigma sigma? Then what will happen? Electric field in region A, sigma 1, sigma 2, what are? Sigma. This will become minus sigma by epsilon naught. Electric field in region B, sigma 1 minus sigma 2, that is sigma minus sigma, 0. Electric field in region C, sigma 1 plus sigma 2, sigma plus sigma 2 sigma, that is sigma by epsilon naught. This is the first situation. Case 2. Case 2. Sigma 1 is equal to sigma and sigma 2 is equal to minus sigma. Okay. So if I put, that means these are situations. Sigma. This is a situation minus sigma. Then here there will be two field because of 1 left, because of 2 right. Here because of negative towards it, because of positive away from it. This is E2, this is E1, this is E1, this is E2. In between because of positive away from it, because of negative towards it. So in between both the fields will be in the same directions. Here they will cancel each other, here they will cancel each other because the surface charge densities are same, okay, but they are opposite in nature, so they will become equal and opposite. Or we can use this particular situation to derive the final situation here, A, B, C. Electric field because of A, sigma 1 is equal to sigma, sigma 2 is equal to minus sigma, that is sigma minus sigma. How much will become? 0. In situation B, sigma 1 is equal to sigma, sigma 2 is equal to minus sigma, minus and minus will make it plus 2 sigma by 2 epsilon naught, that is sigma by epsilon naught. Electric field in situation 3, sigma 1 is equal to sigma and sigma 2 is equal to minus sigma. So sigma minus sigma will become again 0. So that is why in this particular situation, when one surface is positive, the other surface is negative, here electric field is 0, outside electric field is 0, only in between electric field is sigma by epsilon naught, which is from the positive plate to the negative plate. Okay, in case of two plates, plus and minus, two surfaces, plus and minus, outside electric field is 0, outside electric field is 0, in between electric field is sigma by epsilon naught, direction from positive plate to the negative plate. Is that okay? Okay, now let me come to this problem again. Let me come to this problem once again. Let us discuss a problem here. There are two plane sheet of charge. One is having plus sigma. This is another plane sheet of charge having minus sigma. One is positive, the other is negative. So these are charges. There will be either attraction or repulsion. Since they are opposite, between them there will be a force of attractions. Okay. Let me call the area is A. Area is A. Total charge here is plus Q and total charge here is minus Q. Right? Then we understand. Q is nothing but sigma into area. What you have to find here? Find force between the two surfaces. Find force between the two surfaces. Okay, so they will exert a force on each other. What is the force between the two surfaces? Okay, if we are given 2 point charges Q1 and Q2 separated by distance R, we have to find the force between them. What do? We know the second charge is in the electric field of the first and first is in the electric field of the second. So there will be electric field E1 because of the first and there will be electric field E2 because of the second. So if I have to calculate the force on 1 by 2, force on 1, I will be writing charge on 1 multiplied by electric field of 2. Okay, what is the electric field of 2? K Q2 by R square. So this is K Q1 Q2 by R square. Similarly, if I have to find out the force on 2 by 1, then I'll write charge on 2 multiplied by electric field because of 1. Q2, what is the electric field because of 1? 1 के लिए यहाँ electric field कितना होगा? K Q2 by R square. K Q2 by R square. It is because of 1. K Q1 by because of 1. K Q1 by R square. So the again force K Q1 Q2 by R square. So the negative surface is in the electric field of the positive surface and a positive surface is in the electric field of the negative surface. Okay, so if I consider only the positive surface, for example, for the positive surface at a certain distance R, suppose their separation between them is R, at a certain distance R, electric field will become how much? Sigma divided by twice epsilon naught. Electric field because of one surface. Electric field because of one surface. Electric field because of one surface. How? Sigma divided by electric field because of one surface. Sigma divided by twice epsilon naught. इसीलिए यहाँ पर जो इलेक्ट्रिक फील्ड होगा, ओके, जहाँ पर ये नेगेटिव सरफेस है, यहाँ पर जो इलेक्ट्रिक फील्ड होगा वो पॉजिटिव सरफेस के लिए होगा और पॉजिटिव सरफेस के लिए इलेक्ट्रिक फील्ड कितना होगा? सिग्मा डिवाइडेड बाय ट्वाइस एप्सिलॉन नॉट. Now we are at this particular point, this electric field exists. Now we are putting the negative surface. So the negative surface will experience a force because of the field of the positive surface. How much will be that force? Force on negative surface is nothing but charge on negative surface multiplied by the field of the positive surface. What is the field of the positive surface? Sigma divided by twice epsilon naught. Okay, so finally this will become how much equal to minus sigma is again q by area, q into q will make it q square divided by twice a epsilon naught. So this is the force between the two surfaces. Here minus sign indicates the force is attractive. That is all. Okay, check it out. Q square divided by twice a epsilon naught is going to be the force. Okay, so someone can ask you, sir, you have seen electric field between positive and negative is sigma by epsilon naught. Sigma by epsilon naught is the electric field, where in between, this is not the electric field because of one surface, this is the resultant electric field, okay, because of both the surfaces, right? Like the way in this particular system, if you have to find out electric field here, because of positive electric field will come, because of Q1 electric field will come towards right, because of negative electric field will come towards left. But we are not talking about the electric field in between. We are talking how much force one is exerting on the other. So for that we need to understand that the second charge is in the electric field of the first charge. If I call this is the test charge, then I have to call this is the source charge. Or if I call this is the source charge, then I have to call this is to be the Q1 to be the test charge. So इसीलिए यहाँ पर force on 1 by 2 is nothing but charge on 1 by field of 2. Similarly, force on 2 by 1 is nothing but equal to charge of 2 multiplied by field of 1. Similarly, okay, the force on 2 by 1, the force on 2 by 1 is nothing but electric field because of 1, electric field because of 1 multiplied by the charge on 2. Okay, I hope this is clear to you. Check it out. Right? Similarly, if you consider a metal surface, okay, or conducting plate, metal plate or conducting plate. Okay, so when you use a conducting plate, automatically charge will appear on both the surfaces. Here one thing, thickness we are almost neglecting in comparison to the area. Thickness we are almost neglecting in comparison to the area. So charges will appear, uniform charges will appear on both the surfaces. Uniform charges will appear on both the surfaces. The surface which is in the front and the surface which is on the back side. On this side also charges will appear, but okay, fine, we can neglect it. This is too small. Okay. So let me call again sigma to be the surface charge density. So this situation is something going to be like this, as if there is one surface with positive charge and there is another surface with positive charge. Okay, both are sigma and this is also sigma. Okay, this is inside the metal, inside the conducting plate, So this particular situation is going to be like this particular case, sigma 1 is equal to sigma 2 is equal to sigma. So what will happen on the side A? Matlab, this is the situation A, this was B, and this particular situation was C. Here, because of both the surfaces, sigma by twice epsilon naught plus sigma by twice epsilon naught. Okay, sigma by twice epsilon naught plus sigma by twice epsilon naught. How much will become? Sigma by epsilon naught. Here will become again total minus sigma by epsilon naught. In between, electric field will become how much equal to? In the region B, electric field will become equal to 0. Okay, so this particular situation is exactly similar to this situation we have discussed earlier. So for a metal plate or metal surface, this is going to be the case. For a metal plate or metal surface, this is going to be the situations. Okay. Now let us discuss another problem out here, a very common problem. let me consider a surface, simple surface, a surface having charge density as sigma. What charge density? Surface charge density. Okay, from this particular surface, okay, at one point a thread is fixed. At the end of the thread, a bob is given, a bob having mass m, charge q. Okay, so the bob is having charge. This is vertical. Surface. So the bob is in equilibrium, making an angle theta with the wall, with the surface. Bob is in equilibrium, making an angle theta with the surface. You have to find out the tension in the string. Find tension in the string. Okay, or you have to find out at what angle the bob will remain in equilibrium, or you can find at what angle bob will be in equilibrium. So in order to discuss this particular problem, we need to understand there will be two forces. One is force on the bob, which is charged into electric field. The other is the force on the bob due to its weight mg. So there are three forces which is putting the bob in equilibrium. There are three forces which is putting the bob in equilibrium. Clear? So in order to solve the problem, we can simply use this particular situation. This is mg, this is q, into E is nothing but sigma by twice epsilon naught, and on this particular side there is tension. Okay, this particular angle is going to be theta. Since this is theta, this side is t cos theta, and on this side is t sin theta. So therefore basically if we go here, t cos theta will balance mg and t sin theta will be balancing q sigma by twice epsilon. So from equation 1 and equation 2 you can get what the value of tension and angle theta. Okay, to get tension, to get the angle, divide equation 1 equation 2 by equation 1, you will be getting tan theta. Tan theta will become how much? Q sigma divided by twice epsilon naught divided by mg. Okay, so theta is equal to tan inverse, rest you know. Okay, and to get a value of tension, square equation 1, square equation 2, then add it. T square cos square theta, t square sin square theta, t square common, put in bracket cos square theta plus sin square theta will give you how much? 1. And on the right hand side, how much will become? mg square plus q sigma by twice epsilon naught square. So from here you will get tension is nothing but mg whole square plus q sigma by twice epsilon naught whole square. Okay, so let us stop here. Rest I'll continue if necessary in the next class. Just have a look at these problems. Okay, see you in the next class.